Today's topic is what's called a box plot and a 5-number summary. A 5-number summary is a measure of spread that consists of 5 numbers that split the data into quarters. When we think quarters means 4 quarters and $1, and we are going to find 4 cutoff points for our data set. We could think about this like a number line, and if we were to envision our number line, our first score would be our minimum, our highest score would be our max, our median is our middle score. Today we're going to introduce 2 new ideas. The one is called Q1 and the second is called Q3. And you can basically think about medians of the first half and medians of the second half. Since half of our data is before the median and half of the data is after our median, then we can also think about how 25% of our data fits into each of these quartiles, which is why they are called quartiles. Another term we will talk about is called the interquartile range, or IQR for short, and this is the middle 50% of the data. To find the middle 50%, we are going to take Q3 and minus Q1. Now, when we are figuring out our data, if there are an even number of data points, then you're going to average the 2 that are in the middle. We will talk about a couple scenarios as to how we find our median, Q1 and Q3, based on different values of number sets, and we'll probably refer on that some more in class. Box plots. This is a graphical display of our 5-number summary, and our box is going to consist of a whisker, which will extend to the low and the high, and then a box, which will demonstrate where the middle 50% of the data lies. Okay, if we take a look at the stem plot below, we want to first figure out our 5-number summary, which is the min, Q1, median, Q3, and max. The way that I go about doing this is I first find my minimum and my maximum. Now, if we look at our data set, our minimum is our first value and our maximum is our last value. Now remember, we need to consider the way that our stem leaf plot is given to us. So the minimum is not 0, it is 70, and the maximum is 126. Now, if we count, there are 12 data points. So to find our middle value, we would do 12 divided by 2, which is 6. Since that is an even value, we are going to average the 6th and 7th score. So if we look on our chart, 1, 2, 3, 4, 5, 6, that right there is where my median is located. This is going to split my data in half. Okay, so my median is the average of 96 and 96, which is just 96. Now, when I go to find my Q1, I have 6 scores in my top half. So again, 6 divided by 2 is 3. I'm going to average my 3rd and 4th score. And my Q1 would fit here. So I need to average 83 and 90, which gives me 86.5. To find my Q3, I'm going to do the same thing. I'm going to, since I have 6 scores in my upper half, I'm going to average those as well. So I will be averaging 105 and 114, which gives me 109.5. To find my IQR, I do Q3 minus Q1, which is 109.5 minus 86.5, giving me 23. So if we take a look at what this tells me that the middle 50% of the data spans 23 data points. When I go to make my box plot, I'm going to draw a number line, and this number line will look like this. Since my minimum is 70 and my maximum is 126, I'm going to label it going from 70 to 130. So I have 70, 80, 90, 100, 110, 120, 130. From here, we put a point at each of these 5 numbers. So I'll put a point at 70, 86.5, 96, 109.5, and then 126. From here, I draw a rectangle that starts and ends with my Q1 and Q3. I draw a vertical bar to represent my median, and then I draw the whiskers to show the min and the max of where my data extends. and this is how we make a box plot. Now we've talked about resistant and non-resistant data sets earlier when we were talking about mean and median. And the question below asks, how would we describe range and IQR in terms of those statistics? And we would say that our range is non-resistant. It's not resistant because one extremely high or low value is going to make the range appear much greater than it is. The IQR, however, is resistant, and it's resistant because it only focuses on the middle 50%. And a lot of times we will talk about the spread of our data and the center of our data, and so yeah, we might have one high or one low score, but what we really care about is where the middle 50% of the scores lie. For the following example, please calculate the 5-number summary and then make a box plot below. When we go to calculate our 5-number summary, we'll see that we have 15 values. 15 values means that 15 divided by 2 is 7.5, therefore the 8th value is our median. So if we look at our scores and we count in 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8, this right here is our median. Now, when our median is a specific value, we don't count it anymore when we're finding our Q1 and our Q3. So my minimum is 89, my maximum is 152, and my median is 118. Now, when I go to find my Q1, I have 1, 2, 3, 4, 5, 6, 7 remaining scores. Since that's also an odd number, in this case my Q1 is the 4th score, and my Q3 is also the 4th score, giving my Q1 to be 103 and my Q3 to be 137. My IQR is 34. When I go to make my box plot, I'm going to label my axes. I need to go from 89 to 118, from 152, so I'm going to start counting at 80, and then just like I did on the previous problem, count by tens. And then from here, we're going to get and put a point at each of those 5 numbers. And then we draw the rectangle to represent the middle 50% and the whiskers to represent the max and the min. Pause the video and answer the questions below. In this box plot, we can see that the 5 numbers are clearly labeled. We know that the value where we see the vertical bar is our median, and the value where we see the start and stop of the rectangle is our Q1 and our Q3. The Q1 is 10, I don't know why I wrote 14.5 there, and the Q3 is 24.5. To find the percentages of data in between these regions, when we try and figure out the percentages between each of the data points, remember that each one of those quartiles represents 25%. So that's why between 10 and 24%, which represents 2 regions, is 50%, less than 24%, because that represents 3 regions of data, is 75%, and between 5 and 10 is our lower quartile, that's why that's 25%. Greater than 32 would be nothing, because 32 is our maximum score. The last question says, the second quarter of data appears to be longer than the third quarter. What does this tell us about those regions of distribution? And as we can see here, the second quarter is much more spread out. It goes from values of 10 to 21, whereas the next quarter goes from regions of 21 to 24.5. That basically means that the third quarter is much more condensed, whereas the second quarter is much more spread out. If we were to draw a curve for this, it would look something like this. We can see if I look up on the box plot that the data would look like this, and then be much more condensed, and like this, which means that our graph would be skewed left with a tail on the left. Again, I don't know why I had that error. All right, homework is worksheet 5.